All right, so welcome to another edition of Nerd Shirt Friday. Here's today's nerd shirt, which I thought was appropriate given the chemical reaction uh, video from earlier in the week. So I got one question so far. Keep them coming. I will answer more in the future. But I thought I would throw in a couple of sort of classic ones as well, just sort of from the archives. The first one, actually, first quick update. I went to the store today. I think I'm going to call this look Easter egg Kylo Ren. Just FYI. So anyway, classic example. This is actually the one I usually give at the beginning of the year. Why is the sky blue? Well, if you Google this question, the first link I think that comes up is a great link to NASA. Go figure. But the basic explanation is this: when we look up at the sky, what we're seeing is the blue light from the sun, right? Because the light from the sun has all the colors. It's white, it includes everything. And when you put it through a prism, you get to see all those colors. But what happens is the blue light, the spectrum and the range of colors that we call blue, has a very specific wavelength. We talked about wavelength actually back at the beginning of the year, near the beginning of the year anyway. And the wavelength of blue light, colors in that range of light in the range of colors we call blue, is close to the size of molecules and bonds and molecules in the atmosphere. So the light, as it comes through, most of it is too big to be interfered with, or doesn't get scattered very much. It passes through the atmosphere pretty easily. But the blue light, because of its wavelength and because of the size of the particles and molecules in the atmosphere, gets scattered. Okay, so it sort of deflects off in all sorts of different directions. So that's the light we see when we look up at the sky, and it's blue. Now, we all don't look blue to each other because by the time the light gets down to us, the blue light has been scattered around a whole bunch more, and all the other colors are kind of coming in too. So it kind of gives us that white feeling again, of white light, all the colors of the spectrum by the time it gets to the ground. But when we're looking up, we're seeing the atmosphere reflecting that blue light, or scattering rather the blue light. This is also related to sunsets and why the colors of a sunset are the way they are. And it has to do with the fact that as the sun gets farther and farther down near the horizon and just past the horizon, the blue light being scattered by the atmosphere now can't get to us because it's kind of being bounced off in directions that are at an angle that we can't see or can't see as much. But the other colors, the reds and yellows and oranges, which have longer wavelengths, are still passing through the atmosphere at an angle that we can see. So that's why it looks more red and orange. And that's also why if you've ever been in an area where there's been like a dust storm or a forest fire or like a volcano, anything like that, you get these very vivid, long red sunsets because the particles, the bigger particles of dust and smoke and things like that, now are starting to scatter the longer wavelengths of red, orange, and yellow light. So, and the blue light can't even get through. So that's why you have that effect. Which the scattering of light and stuff kind of leads me to another question, which is about rainbows. This is honestly kind of one of my questions, but does everyone see the same rainbow? The answer to this is no. Now that doesn't mean that you can't be standing next to somebody else and you both see a rainbow, but the rainbow, the colors that you see, right? I think most of us probably know that the reason you see a rainbow is that there's water in the air, and the water acts like a prism, and it scatters and separates the light. As the white light passes through the water droplets, certain colors get through faster and come through at a different angle, and then other colors get through slower and they go at a different angle, and so you get that banding of colors based on the wavelength as it passes through the water. But the thing is that the colors and the actual rainbow that we see is very, very specific to an angle of approach. So what that means is you have to be looking, the light has to be coming through the water in the air at a very specific angle for there to be a rainbow. That's why there isn't a rainbow every time it rains, and that's why sometimes you can see a rainbow and then like kind of look up again and you don't see it. Because if the angle changes at all, you might lose that effect. So technically, you could be standing right next to somebody else, but because they're not looking at it from the exact point of view that you are, you're actually not looking at the same rainbow. You're looking at two different rainbows, even though they might be there at the same time. So then the last question, which is the one that was submitted, is why do we sometimes have that sensation of falling, even though we're sitting still or laying down? This happens a lot. You wake up because you have a sensation of falling, or you have a dream where it feels like you're falling, and you have that moment where you wake up. So this has to do with something that, I'm not saying that we've all done this, but if you've ever been sitting in a class, for example, or a meeting, or at work or something, and you nod off, and then your head jerks up. Okay, that's a reflex, right? Your inner ear tells your body as your neck muscles and sort of back muscles start to relax and your head falls forward, well, or back. Your inner ear picks up that sensation and registers that you're moving too fast and you're falling, and that sort of snaps you awake. Well, there's something similar that goes on. It's called a hypnic jerk, and when you can be sitting perfectly still or laying down, and this actually happens a lot when you're falling asleep, because as your muscles relax, sometimes there's actually a spasm. That's the hypnic jerk, and the spasm of your muscles creates a disequilibrium in your inner ear. So the fluid in your inner ear gets stirred around by this sudden jerk, and then it gives you a sensation of falling, and you sort of snap. And a lot of times you don't register the muscle spasm, A, because it's really quick, and it might be very minor. It doesn't take much to throw off your inner ear. And B, the sensation, a lot of times, again, it's because you're starting to relax, and so you don't even realize that you've had that muscle spasm, because it doesn't take much. So this is a great question. Ask all your questions. I'd like to answer them. Again, if I don't get a lot of questions, I'll start coming up with my own. I've got a couple more in mind that I'll throw out there if I don't hear anything else by next week. I had hoped to post a couple more experiments this week for Nerd Shirt Friday, but the weather kind of put a stop to that. I was hoping to get outside and do some stuff today, but couldn't really do that today. So next week, I'll try to plan ahead, and any nice day, I'll try to do the experiments, or I might be able to do one that I have one in mind that I might be able to do inside that I can talk about next week if all else fails. But if I have nice weather, I'll get outside, do it, and save the indoor one for the week after. All right, so we're going to keep going. There'll be a new update on Sunday with the schedule for this week's Google Meetings, and then I will be posting the next assignments starting either Sunday night for Monday or Monday for early Monday morning. If you are having any trouble accessing any of the assignments, I've gotten a handful of emails about trouble with Edpuzzle. If this is you and you haven't already emailed me about it, please do, so that I can figure out if there's maybe something specific that's triggering these problems, or if it's widespread. I can see a bunch of people have done them, so I know it's working for some people, and that's not a big deal. But if you're having trouble with that, please let me know so that I can try to diagnose the problem or come up with an alternative that might work better for everybody, because we all need to be able to access the material. All right, so have a great weekend. Stay safe. Wash your hands. Take care.